Hello, Mr. Dewan. This is FRQ number 5. So, part A asks for a free body diagram. That's the box. So, acting straight down is f of g. Acting up in that order, that's f of n. Acting against the block, that is f of k. What's pushing the block is f. And that is it without changing any angles. So, part B asks to find contact force. So, we know that the net contact force is equal to 0 because the object does not move in the y direction. So that means that f of n minus f g y minus f y is equal to 0. F of n is equal to, you add both of these and they break up into m g cosine theta plus f sine theta. And that's f of n. Part C asks, okay, so to find the acceleration of it'll be f of x, which is the applied force, minus f of k, which is the friction, minus the gravity in the expression, and that's equal to maximum acceleration. So f of x is the same thing as f cosine theta. F dx is the same thing as f. That's the same thing as m g sine theta. And fk is the same thing as f n mu k. So we know that, and that's equal to ma. When you divide by m, and we get but we can substitute fn for mg cosine theta plus f sine theta because it's being pushed by, because the okay. Here we substitute fn to simplify it, and fn's like this because the it pushes up, and which makes it different. And that is acceleration. Okay, so we need to develop an expression. So D is asking to make an expression where velocity is constant. So v is constant when x when a is 0. So that means that f of x minus fk minus fgx is equal to 0 because assumption is 0 to have a constant velocity, and that means that fx, which is f cosine theta, is equal to fk plus mg sine theta. And this means that we can fk is the same thing as fn uk. So f cosine theta is equal to I can leave it as this since it doesn't ask for anything else. For the second part, this has to be meaningful because it has to be meaningful when f cosine theta is greater than fn mu k. So this is when cosine theta is greater than sine theta mu k, and this means that if you divide sine over, we cosine theta will be greater than mu k. And that's when the relationship is successful. Okay, so for E, we know that fx, so ma, so a is 0.5 and m is 2, so ma is 2 times 0.5, and it'll be f cosine 20 minus f k minus f g x. So f cosine 20 is equal to 1 plus fk is the same thing as fmuk, which is the same thing as this. Plus fgx is the same thing as mg sine theta. So you plug in the numbers, so and you divide cosine 20, you plug in the numbers, so f is equal to 1 plus 2 times 9.8 cosine theta cosine theta is 20 plus f sine 20 times mu k is 0.33 plus 19.6, which is 2 times 9.8 times sine 20. You plug it in, you get about 1 plus 6.077 plus 0.11 f plus 6.7 divided 6.7 divided by cosine 20 is equal to f. So it should be f is equal to 14.66 plus 0.12. So you subtract that over, it divided 0.8, so f is equal to 14.66 over 0.8, which is 0.88, which is about 16.6 newtons. Part F asks for m and keeping it motionless. So that means that fx minus gx because assumption has to be, because that will be the best way to get to 0. So f cosine theta minus, well, f cosine theta is equal to mg sine theta plus this, you divide by cosine. So f cosine theta minus f mu k sine theta is equal to mg sine theta plus mg cosine theta mu k. You factor out f and you divide by this. is equal to mg sine theta plus mg mu k cosine theta. I just have to divide this over so f is equal to this. Oh, I forgot to put 5 at the start of everything because there's a new block, so there should be 5 in front of all the mg's. Yeah, now we box the answer. Okay. So for part G, it asks to calculate force F. So we can just use the formula we just derived to do it. So F is equal to 5, M is 2, (9.8) sine 20 plus 5, 2, 9.8 times friction, which is 0.33. Cosine 20 divided by cosine 20 minus 0.33 sine 20. And when you do this, you should get plug in the calculator and you should get 77.3 newtons. And that's your F. Part H, okay, so concept force using those. So F M 4M minus F K minus F G X of 4M is equal to 4MA. So this is the same. 4MA is the same thing as 4. The mass is 2 times 0.5. FK is the same thing as FMUK. fgs is same as 4mg times sine of 20 so fm4m is equal to 0. Oh wait, no, it's equal to 4 plus fm is the same thing as 4mg cosine 20, which is times 0.33. You don't add anything or subtract anything to it because only because you already because there's like no y direction that affects it. If you plug this in your calculator, you should get and this is equal to 55.1 newtons. Now part I asks like that. Okay, so fk minus fgx is equal to 2 times mass and acceleration to system s. So k is minus fg. So fn is the same thing as fn. I mean fk is the same. Fn and vk is the same thing as wait, no. F n mu k minus fgx is the same thing as 2 times 2 times 9.8 times sine 20, and that's equal to 2 times m, which is 2 times a, which is a is net force minus m, net force over m, so the the net force is about 0.3 FM, so you add that, so now Fn is the same thing as Fg cosine theta mu k. That's equal to 14.6. So Fg, so M, you divide, so mu k is equal to 14.6 over 19.6 cosine 20. Times 2 using that, so mu k is equal to 0.397. Yeah, thank you, and goodbye.